Hi guys, it's Engineer Augmented Formula here. So welcome to our first class on YouTube, and I'll be teaching you how to derive the quadratic formula using my own method, not the conventional completing the squares method. All right, before we go on, please do not forget to like, share, and subscribe to my YouTube channel. Now, as we all know that the quadratic equation is generally in this form: ax squared plus bx plus c equals 0. So this is the general form of the quadratic equation. But when we want x squared to stand alone, we simply divide through by a so that x squared will stand alone. So here we have x squared plus bx plus c equals 0 over a over a. So this is another form of the quadratic equation. All right. So I thought to myself, to get a quadratic equation, two linear functions have to multiply. E.g., we can have, let me write it here, x plus a certain number times x plus a certain number, such that when this guy opens the bracket, we'll have x squared, which will lead us to the quadratic equation. So then I said, what if I keep a certain value p? I don't know what it is, but let's just say a value of p, and I square it. This will give us a quadratic expression. This will give us a quadratic expression if we expand it. But then also, if x plus p was a positive number, say 2, 2 squared would have been 4. But if x plus p was a negative number, let's say minus 2, minus 2 squared will also give me plus 4. So that means x plus p will give us a particular number, which is a constant value. That means x plus p will give us a constant number. So it means that x plus p can be two possible values, either the positive or the negative. So take note of that. So then, let me try to expand this guy. When I expand this, this is x squared plus 2 times x times p. That is 2px plus p squared equals q. Then when I take q to the other side of the equation, I will have this. So this is also a quadratic equation. Then I want to compare this quadratic equation with the one above, which is x squared plus bx all over a plus c equals 0. Now x squared goes with x squared, makes sense. Now this guy has x, this guy has x. So if I'm comparing, it means that 2p will be compared with b over a. That means 2p is equals to b over a. Now when I divide both sides by 2, the 2 comes here. So p becomes b over 2a. So take note of this answer. It's very important. Also, when I compare these two guys, these are like the constants of both quadratic equations. This tells us that p squared minus q is equals to c, which also means if I take q to this side of the equation, I will have p squared minus c equals q. That means I'm taking c to the other side of the equation. So q is this guy. Now, what is the value of this side is c over a. C over a. So this is c over a. Now, what is the value of p? We are going to substitute the value of p here. P is b all over 2a. So instead of p square, I'll be having b all over 2a all square minus c over a. That will be q. This leads us to b square all over. If I square 4, 2, I'll get 4. Then a square. This equals q. So that means q is equals to, the LCM here is 4a squared. So 4a squared divided by 4a squared will give me 1. 1 times b squared will give me b squared. 4a squared divided by a will give me 4a. 4a times c will give me 4ac. So this becomes the value of q. So we have gotten the value of p and we have gotten the value of q. Now remember that we said from here, take note of this guy. We said that x plus p all square is equal to q. So this implies that x plus p will be square root of q, but has a positive and negative value, because the square root of 4 is plus or minus 2. So this also implies that x is equals to minus p plus or minus square root of q. I took p to the other side of the equation. So basically, I'm going to substitute the value of p that we had here and the value of q that we had here. So x is equals to minus p. What is p? B over 2a plus or minus square root of, what is q? Q is b squared minus 4ac all over 4a squared. So the square root of this guy, this denominator, is easy. That would be 2. Square root of 4 is 2. Square root of a square is a. But the top is somehow complex, so we can't really find square roots. Now, what's the final LCM? The LCM is 2a. So x becomes, the final LCM is 2a. We have minus b plus or minus square root of b squared minus 4ac. This becomes our quadratic formula using the completing the square method in this form. So that will be all for this video. Please do not forget to like, share, and subscribe to my YouTube channel. Thanks for watching.